Hello students, welcome back to my channel Infinity Minds, where maths is made easy. Today we shall be doing class 9 Ganita Manjari's chapter number 4 Exploring Algebraic Identities, third part. Okay, so without wasting time, let us proceed. We will now begin with the fourth exercise. Till the third exercise, the videos are already uploaded, so you can go and go through them. Let's start with the first question. Fill in the blank to complete the following identities. So in this chapter, we have first of all revised the few identities that we learnt in class 8. And also we shall be doing, and we are in fact doing, one or two new identities will keep getting added. Now here, for example, it's a fill in the blank, but for you, you need to solve it. Blank is only as far as a question if it's a one marker or so. But for you, you have to, calculate the answer. You should be knowing the answer, only then you can fill up. Like s square minus 11s plus 24. What it has given you the hint that you have to express it as product of two numbers. Fill in the blank is basically what is it equal to. Now what is it? It is after all an polynomial in variable s, degree is 2, and you can't simplify it further. They are all unlike terms. You have to express it as product of something. It is about factorizing. It is like factorization that is being asked. You are not being told, but yes, you have to do factorization only. Okay, so how to do factorization? This is through splitting middle term. There is a method called splitting middle term, where what one does is we pick up this last constant term and try and find two equal factors of this in such a way that if I add, I should get the middle term, which is minus 11 in this case, and the product of those two numbers should be 24. We need two numbers such that whose sum is not just 11, in a way it's a minus 11, and you have to adjust the signs in such a way, and the product is a 24. Now see, splitting middle term, see, the point is, first of all, you have to identify. As the question comes to you, you first have to check that is anything coming common and you are able to factorize, or is it through some identity that I can apply. Now, if both the methods fail, then you also have to check, is it splitting of middle term, through that I can solve. Was there a coefficient out here next to s square? So it is the product of these two terms, whose factors here the coefficient is 1. 24 into 1 is 24. So we try and we do factorization to 24 in such a way that we are able to generate those two numbers. Okay, as we'll proceed, we'll practice more on this. Now here, if I have to have two numbers such that if I add them, I get in minus 11. So it is able to think of 8 and 3. The product of 8 and 3 is a 24. And if you add 8 and 3 units, you get 11 units. Yes. But we have to adjust our pluses and minuses. So it would be correct if I take a minus 3 and a minus 8. As if we add them, we'll get a minus 11. Now just see. I will split the middle term minus 11s as minus 8s and minus 3s. This is the most crucial step, that you should be able to think of the correct breakup of the middle term. Now after that, in these two, you will have to take out a common. You will always land up in such a situation where it will be possible. So take out s common, you are left with s minus 8. Out of this, minus 3 shall come out common, s minus 8. Yes, we will get a repeating bracket. We shall get a repeating bracket, which is the hint that that is a major hint that we are on the correct lines. We are not wrong. Okay, that gives us a hint that we are not wrong, children. If you're not getting a repeating bracket, you need to cross-check your steps. Okay, you need to cross-check your steps. There must be something wrong that you must have done. splitting of the term or some plus minus, maybe taking common. But I'm trying to emphasize that that means you must make sure you get a repeating one. Otherwise, you go back and cross check your steps. Okay, so now what happens is that the repeating bracket will come outside common s minus 8 and rest of it s minus 3 is there. Now why is it so? Try to see. AB minus AC. Distributive property, children. Distributive. Remember? Distributive. The number repeating comes outside, rest of the things inside, whether it's a plus or a minus. So this whole thing is playing the role of A in this case in our question. A into B minus A into C. So A comes out and rest of the things S minus 3 in another bracket. Okay. So like this we are going to factorize. So these are the two expressions S minus 3 and S minus 8, two binomials that if I open I shall get this. Just see. S has to multiply with both of them. S into S, S square minus 8S. This one minus 3S and minus into a minus plus 24. Minus 8 and minus 3, that's what we started with, minus 11. Okay. So I have been able to create factors. Factors, you understand, you multiply and you get something. If it's a 3 into 4, 12. So these are two factors of 12. That if on multiplying these two, I am getting 12. So that's what we want to do for a polynomial. We want to break the polynomial into two parts such that on multiplying those two parts, I should get the point where I have started with. Okay, let's start. Let's begin with the second question. Dash into x plus 1 is equal to this. What does it mean? Try and always link it with something easy. What do I multiply 3 to get a 12? You are getting a product. Obviously, so answer divided by one of them shall give you the other. Okay, answer divided by one of them. That is one way of looking at it. But I must simplify my given expression, get the expression that I have in hand. So again, what is happening to me? Okay. And my pen erasing this thing. So as I had told you, the coefficient of this 3 into 7 is 21. If I, as such 21 itself has only this, if I do the prime factorization for 21, I only get this. 3 and 7 are the only factors. If I adjust my 3 and 7 units, I will get a 4, and if I multiply, I get a 21. But I must adjust my pluses and minuses. So minus 4, I have to add. So I must put the minus with the bigger number. Integers rule, sign of the higher one. So I shall break it up as a minus 7 and a plus 3. The addition would be a minus 4 and the product will be a minus 21. Clear? Step 2, take common. The way they are arranged, that itself is sufficient. No problems. You could rearrange also, even if you don't. The way they are put, it's absolutely okay. Take out the common. X is common. 3x minus 7 is inside. Plus, nothing common means 1, children. Doesn't mean 0. Nothing is common. It is the one which is common because it's a product after all. So inside we are left with a 3x minus 7. See, we are getting a repeating bracket. 3x minus 7 comes outside. X plus 1 is left inside. Now what else? Now try to match it. That if the answer itself is 3x minus 7 into x plus 1. You made factors of the answer. The x plus 1 should come here, as I told, no, answer divided by this. So 3x minus 7 has to come here. That's it. If you multiply these two, it's your way of looking. Either you factorize, you can compare and fill up the blank, or you have to divide and fill it up. Okay. We'll go to the next question now. Okay, these are just hints. Basically, you have to get the answer. 10x square minus 11x minus 6. Try to think trick number 1. We have to think of something which is coming common. Is anything coming common to all the terms? No. Wait, number 2, is any of the identity valid? A plus b whole square, a minus b whole square. Are there square values? No. We were making square or roots of these, no? So the third one, we shall try to look out for uh, a splitting middle term method, and also splitting middle term, you must look out for a quadratic expression like this. A quadratic one where you can see ax square bx plus c, that they are different, there is nothing common, will most probably with that that is the one which happens with splitting middle term. Okay, splitting middle term, just don't forget. So here, coefficient of x squared 10 into 6. No, it's a 10 into a minus 6. I always emphasize the sign of the number is before. Okay, yes, it's a minus 60. But nobody does factorization to minus 60, children. It is the 60. The minus, the signs we shall adjust in the end. So, doing factorization to 60, 2 into 30, 2 into 15, 3 into 5. Out of these numbers combination only, you have to create an 11 in such two factors in such a way that adding gets me a minus 11, products gets me a 60. Okay, so if we try to see, 5 into 3 is a 15 and 2 into 2 is a 4. So 15 and 4. See, product, any combination you pick up, the product is going to be this, because you're making factors to this number only. That's not a point. That's not a problem. But you have to frame it in such a way. Like I could have taken a 2 and I could have taken a 30. 2 and 30 will also give me 60. But that shall not give me 11. But if I take a 4 and a 15 units, that can give me 11 and product is 60 in any of the cases. Okay, that we have to see which combination is working out. So in this case, the 4 and 15 shall work out. Since I have to have a minus, so I must give the minus to the bigger integer value, 15. If I take minus 15 and plus 4, I get my answer as minus 11, and my product of minus 15 into a plus 4 is going to be minus 60. That's what is desired. Okay, so splitting minus 11 as minus 15 and minus plus 4x. Now, step number 2, groups of 2 each take common. From this, 5x will come common. You understand? From the coefficient also, the number value, the number coefficient will come common. From x square and x will come common. Now, 10, if 5 is a 5 into what can give you a 10? 5 into 2, x into x, 2x minus 5 into 3 plus 4x and minus 6. So 4 and 6, 2 will come common, 2x minus 3. Again, a repeating bracket. Okay, again a repeating bracket has come. So the repeating bracket 2x minus 3 will come outside, 5x plus 2 inside. So 2x minus 3, 5x plus 2. Clear? So now we'll go to the fourth one. 6x squared plus 7x plus 2. Quadratic splitting middle terms before looking at the answer. 6 into 2, 12. Do the factors of 12. 3 plus 4 is 7 units. 3 into 4 is a 12. Taking common, 3x comes common, 2x plus 1. 2 comes common, 2x plus 1. Children, practice them. Splitting middle term is a must. That is, I believe, one short question you get. It's very scoring. So this is factorized into these two. Okay, this was a simple one, all addition signs only. No adjustment of the sign. Coming to question number 2. So entire question 1, whether it framed in the form of filling the blank, for you it was a proper question of getting you practice for splitting middle term. Factorizing, making factors to a polynomial using different ways. Question number 2. Select and use the identity that will help you to find the following products without multiplying diagonally. Basically, application of certain identities, and no one is asking you to actually multiply 41 into 41. Okay, that is not to be done. You have to make sure you use an identity. Which identity? This is repetitive. I believe we've done in the previous exercise. 40 plus 1. You must mention the identity, as I've said, since they are asking you to decide on the identity yourself. Yes, no doubt, plus identity is the one which is suitable. Subtraction won't be suitable in this case in any way. Square of the first term, square of the second, twice the product of the two. 4 4s are 16, double 0, 4 into 2, 8 with the 0, 1. 1681. 27, 30 minus 3 is sufficient. 30 minus 3 is sufficient to write this. So square of 30, square of 3 minus 2 into 30 into 3. 909 minus 180, 729. 23 into 17. Yes, you haven't practiced of this type. If they have already given you a hint, you have to make sure you use an identity. Which are the identities you know? Think on those lines. If a plus b is not valid, a minus b will not work out. So let us try for a square minus b square or x square minus y square, whichever way you frame it. So difference of the two, how is it framed? Like they both are at a constant difference from a third number. There is a connecting number from which either of them is equidistant. 3 units in the plus direction, 3 units in the minus. That number is 20. 20 plus 3, 20 minus 3. So, the same two different numbers are being added and subtracted. It is following this form. X plus y, same two numbers added then subtracted. So, it is the square of the first minus the square of the second. 20 square minus 3 square. Direct identity application. Okay. 400 minus 9, 391. Next. These are all repetitive practice questions, children. 135. It's your way, how you wish, you feel comfortable. Like I am 100 plus 30 whole square. Somebody may write 140 minus 5 whole square. Either you are told, if you are told using a plus b, then you should be able to think of using a minus b, or you have the choice of applying identity. The one you apply, write that. The one you are comfortable with, do that. That much freedom is there. So like I'm okay with 100 square because 100 square comes directly. 35 square. Yes, as I've been telling, those who watch Infinity Minds video will get to certain tricks in between also. See, to getting a square of a number ending with digit 5. Why did I break it as 100%? 3 into the next counting number, 3 into 4, 12, and 5 into 5. That's our answer. Okay. Any number ending with digit 5, if you have to get the square of that, see, number ending with 5, you've done square roots, and 5 5s are 25. The answer shall always end with, the product will end with a 25. What about the prefix? What before that? The number that you have is to be multiplied with the next consecutive number, 3 into 4, 12. That makes up your answer. For example, I'll take up any other number practice with you. Say 75 square if I have to calculate. 7 will be multiplied with the next counting number, that is 8. And 5 is always to be multiplied with 5. 8 sevens are 56, 5 fives are 25. Writing this is also not required. By the time you practice, it comes mentally to you. 7 eights are 56, 5 fives are 25. Okay, one last for practice. Say even if it's a 95 square. 9 into the next counting number 10, that is 90, and I know 5 fives will end with a 25. See how quick it is compared to if you actually calculate 95 square even with these tricks. Okay. Good, no? Learning a trick for numbers ending with digit 5, square of that. Okay, coming to that, so 35 square is a 1225. And now adding will get you all of this. I hope you can do. You can first try and solve, then refer to the slide answer. 100 minus 3 obviously it should strike you. 90 plus 7 is not preferred. 100 square, 3 square minus twice of 100 into 3. Very simple for you. Mention the identity being used. Now, okay, I have written. This isn't falling in either of the three. Neither a plus b nor a minus b, neither a plus b into a minus b, which you are using. You are using in a way three varieties. There is one connecting number, yes, we've decided for 20. 20 minus 2, 20 plus 9. So one connecting number is going to be there. So, but the other two are going to be different. So basically there is a variety of three numbers. Then this is identity number 4. This was also taught in class 8, I suppose. So this becomes your x. Whether it's a minus or a plus, minus is always adjusted accordingly. But it's about x plus a into x plus b. What are we trying to say? That there is a term x that repeats and rest of them are different. So what happens is the repeating number square, x square, and then the a and b are added, that is minus 2 is added to 9, which is a minus 7 into the value of x added to the product is minus 2 into plus 9, that's a minus 18. Okay, x plus a into x plus b is your x square plus a plus bx plus eb. Okay, so the repeating number square will come. The other two a and b's will be added and multiplied with the value of x to be added to the product. So minus 18 minus 7 into 20, that's plus 7 into 20, that's a 140. 400 minus 18. Okay. Again, x plus a into x plus b, 38 square minus 4 and plus 5 is a plus 1 into 38 minus 20. 205, 200 plus 5. I have just moved on because I really feel that's very simple and repetitive for you to practice. Coming to question number 3, again factor the following. Find factors to this. Direct application of your new identity that you have. Now see, what I'm trying to emphasize, how are you going to decide as you get it in your test or wherever you are facing it, okay? That if I see, can I apply my a plus b? No, there aren't three terms. For all the four identities that we have just done in the previous question, a plus b, a minus b, a square minus b square, they are all containing 3 to 4 terms. But this is the one containing 6 terms. So you are required to think of the lines. No, a square, b square, c square. The a plus b plus c whole square identity. Since the question is carrying a, b, c, it is advisable to write your identity in some other alphabets. Let's say x, y, z and vice versa. Okay. So x square, y square, z square, we will try and see if it, the idea is that it should make you think, okay, now I will try to think on this identity. Okay, so is it a square value? Yes, this can be written as the square of 3a, b whole square, 2c whole square. And then you have to check for this. All this also I have explained in my previous video. Twice the product of these two. We will adjust the plus and the minuses I had explained. No, which two terms are carrying the minus. So if it's a this, then that means b must be carrying the negative value because these two are carrying minus with them. Okay, 3a must be positive into a minus b. Then 2 into minus b into 2c, and a and c must be positive, that is twice of 3a into 2c. You can refer to the previous video to listen to this particular type in detail. And we get very clear 3a minus b. Here of course you've written, but it's going to be a, so now if you wish you can put a minus out here. Yes. So yes. One can adjust the minus here. So 3a minus b plus 2c whole square. Going to the next. Is anything coming common? Step 1 we have to think of common. Step 2 we have to think of the any of the identity. Is it a square value? Yes. 4s whole square, 5t whole square. Minus will be copies as it is. Can this be written as twice of these two which you've got? Twice of 4s into 5t. Yes. Sorry, not this. So can minus 40t be written as? Minus will be as it is. 40 is twice of this. Yes. 4s minus 5t whole square using a minus b whole square identity. When you are being told use this identity, it's much simpler. Now, after learning so many, you get a question and you have to think. So, first 2 minutes you have to spend on thinking which variety, which identity, which way will I be able to work it out. It is only through practice, children, you will get used to of how to even think. That is practice, okay? Okay, so as I see with my experience of I can just look and tell, and you because of the answer slide, but as such, your work is anything come step one common? No. Step two, if I have to apply identity, I must get some square values, my dear students. Now, none of R, of course, R square can be written as square of R, but none of them are square values. It's not like A plus B, A minus B, any of the identity. A plus B plus C whole square identity. Can you see 6 terms? No. So, is it a quadratic? Yes. So, chances are for splitting middle term. What is this coefficient is 1. So, 42 I have to factorize. Keep factorizing. 6 and 7 can be the answers as the difference is 1 unit and the product is a 42. 6 into 7. Okay. But for you, yes, if you are stuck, your job is to do the factorization of 42 and check it out. Okay. The factors. So minus r shall be written as a minus 7r plus 6r. Minus 7 plus 6 shall give me a minus 1. Now taking common. Told you from these two r common r minus 7, 6 common r minus 7, r minus 7 is repeating bracket comes. Take it out. R plus 6 will be left. It's very simple once you get used to and you practice it. Okay. We'll go to the next now. Very simple repetitive a plus b whole square, children. This is square of 7. This is square of just itself 1. This will be product. Okay. 7g plus h whole square. Just a repetitive with new alphabets to practice. What should look at before looking forward? 1, 2, 3 square values and 3 total 6 terms. What should it make you think? A plus B plus C whole square identity, students. Okay. You have to look and first of all decide, try and work out. Most probably, yes. If you will, it is going to be. It's 6 terms. Yes, chances are it will work out like this. 64 square of 8, 121 square of 11, 4 square of 2. Now others have to be written as twice of 8 into 11. So 88, 8 to the 16 into 11, sorry, 176. This one is carrying a minus. Now you tell me which these two terms are carrying minus, UW and UV. That means U must be the term. Just a second. UV and UW minus 176 UV. Let's just see. Okay, 32 is 2 into minus 11 into minus 2W plus twice of 8U into minus 2W. VW is positive. Product of V and W are positive. U and W is negative. If U and W is negative, so one of them has to be a minus, the other has to be positive. Out of U and W, one term will be positive. Only that is how the product is coming a negative, U and W. But V and W both are coming positive. UW is a negative, VW is a positive. All this is either to be done in the rough or in your minds, but not on the answer way you solve. And UV is also negative. U into V is also negative. U into W is also negative. Okay. Uh, so accordingly, you will adjust the plus and minus and check out for the answer. The plus and the minus answer. 10 is half the time troubling me so much. 11 into 2, children, 22, it's a positive, into 2, it's a positive 44. As the two of them are carrying negative signs. Then these two, this was to be a negative minus 176. Which two are left now? These two. V into W. Oh, sorry, that we have done. Which one am I missing? First, second, third, and first. The U and the W. U and W again, positive and negative, negative. Okay. So we'll adjust the okay. So we've come to the end of the fourth exercise also. Keep liking the video to support the channel. Okay, we'll now go to the next exercise. Before proceeding to the next exercise, children, there are a set of couple of new identities now to trouble you. But as I've told you, with practice, you can master any of them. Okay, coming to one, now learn them, write and learn them, students. First of all is your a plus b whole square. You remember you have been doing a plus b whole square that you've been doing. This is an a plus b whole cube. Now try and see if a plus b is whole cube. It is basically the base is for that much exponent number of times. So cubing is your, say, power 1 into power 2, right? Bases are same, powers add. I could write it like this. A plus b whole square you have already done, an identity. A square plus 2ab plus b square, whichever way you want to write, a square b square plus 2ab. Now open the brackets and you will get this. This is what it means. Now how does one do multiplication of brackets? Number outside multiplies with each term inside. A shall multiply with this whole square, with this whole bracket, a square plus 2ab plus b square, and b will also multiply with a square plus 2ab plus b square. If you multiply, what does it mean? It will multiply with each of the term a cube plus 2a square b plus ab square. I have simply opened, children. This will become ba square plus 2ab square. Can you see? Can you notice this? 2ab square plus b into b square. That's a b cube. So what are we ultimately getting? Okay, what are we ultimately getting? A cube plus b cube. Now every time we are of course not required to open the bracket and do it. That is why the identity is already written. You have to learn it eventually. A cube plus b cube. Now a square b shall combine with a square b. Can you notice a square b once? 2 and this coefficient is 1. 2 plus 1, 3a square b plus 3b square a. Okay, I shall write the identity once again for you in a little darker shade. What have we realized? Finding cube of a binomial, a plus b whole cube. If you open it, multiply and check out this much part, I can write it as breakup of power 1 and 2. A plus b whole square we've already done. So now we try and open and see. So there are 6 terms, but the like ones will club together. So ultimately we get an a cube plus b cube plus 3a square b plus 3b square a. This is one of our identities that we have to do. A cube plus b cube plus 3a square b plus 3b square a. From this, what happens is, another way to express, both are same. You are very much allowed to write this. Use it. A cube plus, from both of these two last terms, I can take 3ab common. If you notice 3 B, this is b square, a square and a, 3ab. I shall be left with a plus b. So this is what is written. And the very same thing is applied to the case of situation of minus. So in a shortcut manner, the formula has been written here. A cube plus b cube plus 3a square b plus 3b square. You are going to remember. And if you take out common, it's an a cube plus b cube plus 3ab bracket a plus b. Either of the form is okay. These are just each other's form. Whichever way you want to use it, you will end up doing the same stuff only. Okay. And the very same with the minus, you can try a minus b whole cube with a minus b into a minus b whole square. So I would like you all to try out and get your answers. Yes, there would be a answer in terms of with regard to minus also. The answer would be a cube minus b cube minus 3a square b plus 3b square. Okay, if you work out, you will understand. From this only, this gets calculated. That if I keep try and see, this is whole cube. We call it, when you speak, you have to speak a plus b whole cube. And this is a cube plus b cube. This is a cube plus b cube. That is a plus b whole cube. Even if somebody speaks, you should be able to write it correctly. So you must learn this up. A plus b bracket a square minus ab plus b square. In this, a minus b into a square plus ab plus b square. Yes. Learning will only help. You need to learn. You need to practice. They are interrelated. You learn, you practice, you learn. Okay. So they are new for you, of course, I know. But that's what you only have to practice it and learn it. Okay. So in a way, you've learned 4. This is one new identity. From this, you create the minus part also. And from these two further gets created. All the 4 are required, depends on how it is asked in a question. And one last for this. So you are learning 5 new identities before beginning with the last exercise. And there's of course end of chapter exercise also there. Okay. So 5 new identities you must practice. You have to see exactly the same way. In the sense, if you have this, see children, you can always open and cross check whether it holds or not. This is true. It will always be true for any value. If you start opening, pick up one term of this x plus y plus z bracket, first term x with the entire second bracket you multiply, then second term y with the entire second bracket, and so on. So you will ultimately, because there's the minus plus minus terms will cancel, you will get this only. X cube plus y cube plus z cube minus 3xyz is ultimate. So is equal to this only, x plus y plus z into x square y square z square minus xy yz zx. Yes, very similar, and you're bound to get confused. Okay, that both ways it is true. If this is given, that's the answer. If that is given, that is how you can factorize and write it. Now if this thing becomes 0, if you are given x plus y plus z, as you will solve questions, you will understand, children. X plus y plus z is 0. So obviously you are multiplying anything with this whole thing also becomes 0. Basically your entire RHS becomes 0. Critical case, that is one particular case when the sum of these 3 are given to be 0. Not exactly 0. In fact, you have to identify yourself. That you have to check out this is coming out to be 0. That is entire RHS is 0. So if this equation is equated to 0, transposition x cube y cube z cube becomes equal to 3xyz. It is just a particular case of this identity. Identity is this only. This is what is your main identity. Particular case with xyz to total equal to 0. That is, this thing becomes equal to this. Okay. Yes, lot of material for you to absorb. Let us begin doing the questions. Questions are all sum total of what all your previous identities, everything that you have learned till now, children. All the previous 3-4 identities of a plus b, then a plus b plus c whole square, then the 5 new identities that you've just learned. So mixture of all of splitting middle term, all of that. Okay. Now see, in a way there's only one question which has further parts. Simplify the following expressions. They're calling it rational expressions, algebraic expressions, I would say polynomials. Assuming the denominator is non-zero, yes, that is obvious. Division by zero is not possible. That is the reason they are telling you, assuming denominator is non-zero. Fine, we are very much assuming. Point is, you have to, it is saying simplify or solve. How can you simplify? It is through finding factors only. What you have learned in this entire chapter, through finding factors. In order to find factors, you follow various ways. Taking common, identity. For that, you have to check out for square values. Okay, for identity application, you have to check out square values, splitting middle term, and identities themselves are of so many types. Okay, so all of this, it is only through making them, simplifying the expressions through various ways that you have learned in all the previous 4 exercises. Sum total of all of that. It's like the 5th exercise takes care of all the previous one. One question from here and your entire chapter knowledge gets tested. Okay. So job for you, see, we just concentrate on, first of all, the numerator. 3p square minus 3p minus 18q. Still you're stuck, you can't do anything. What do you simplify? They're all unlike terms. And no term like this cancels or anything like that. Okay, it is only in the factor form that you can cancel the terms. You can reduce. So what can, step 1, I look out for common. Okay, 3 is common. Now I'm left with this. I should further be able to factorize this. So what have you done in this? You have first taken out common and then you are applying splitting middle term. So two things you are applying in the same. Yes, no problems. That too only in the numerator. Denominator will have separate things. It's a pretty good long question for you students. First you take common, then you look out factors of 6 such that you get a 1. So 3 and 2. 3 and 2 product is 6 and addition can differences of 1 unit. Minus 3 plus 2 will give you a minus 1. Product will be minus 6. Again p is common. P minus 3. 2 is common. 2q is common. P minus 3q. So p minus 3q into p minus 3q comes out and p plus 2q comes here. So finally the numerator answer becomes this. 3 was already common. Then p minus 3q, repeating bracket, p plus 2q. These are your factors to the numerator. Now factorizing the denominator. Straight away splitting middle term, quadratic. Factors of 10, 5 and 2. 5 and 2 can give you 3 units and also product 10 units. Same steps children, 5 minus 2. From this take p common. From this take something common, minus 2q is coming. Can you identify, can you reach the repeating bracket stage? So that means you are correct. So that repeating bracket comes outside, rest of the terms inside. Rest of the terms inside p minus 2q. Now putting all of them together. Putting all of them together, these two, see. 3 brackets p minus 3q brackets p plus 2q. Denominator p plus 5q. P minus 2q, actually in this case by chance nothing is cancelled. Question would have been better had they given something. And then the factors are the ones which cancel each other. Children, expressions can't cancel out each other. Assuming they would have, so there normally appears a common factor and that cancels. So that is your simplification. Okay. By chance here there is no common factor. Otherwise they cancel. You will have that in further questions. Okay, we'll move to the next. Numerator. Cubic a cube b cube minus 3a square b plus 3b square a. Direct a minus b whole cube identity. What we just did, the one I solved with square and cube. Okay. Direct a minus b whole cube identity, children. a cube b cube minus 3a square b plus 3b square. That's the answer you will get, which I asked you to solve it yourself. Okay, n minus m whole cube. Denominator. What should strike you? Step 1, taking common. Step 2, this is nothing. This is your a minus b whole square. Now try to see. Numerator is n minus m whole cube. Denominator is 5 bracket m minus n whole square. M minus n whole square, right? That's what it shows. Now what do you think? Of course it is explained here. Except that the order of the signs, okay? There is a bracket coming 3 times, there is a bracket coming 2 times. So 2 of the times it will get cancelled. And 1 of the times it will remain as it is. If I take out minus common, I can change. See, we basically have to make the form resemble, nothing else. Try to see. If I take a minus common, I shall be able to make it look like the denominator m minus n. Okay. Now out of the 3 times, 2 times it is appearing. So 2 times it will cancel and 1 time it will be left. So minus m minus n bracket. One can also open the bracket and call it n minus n by 5 will be left. That is how the kind of answer we expect, that you factorize numerator denominator separately. You will have some cancellation and then you get a simplified form. No direct cutting, nothing like that, that this will cancel or the nothing will cancel. You first have to make factors of the expressions given to you. Then if you find something common, do make sure to cancel it. Next, again, now it's only a matter for you to look out for which application of which particular identity. A cube minus b cube. What do you think? Okay, whether it's minus or plus. There are 3 cubic values. 3 like 3 square values. The 3 square values used to come, what was it? A plus b plus c whole square we used to apply. Now if it's 3 cubic values, the last identity that we have studied, a cube plus b cube c cube plus 3abc is a plus b plus c bracket a square b square c square plus b square ab plus bc plus ca. Okay, that particular identity you are applying. The last that we just studied before beginning the exercise. That very last identity we will have, this one, a square b square c square minus ab minus bc minus ca. This particular identity you are going to apply. First of all is your identification of the identity, and yes, then the adjustment of your plus and minus. If it's a cubic value, see, it's pretty simple, and there is a minus, so the minus has to be there because minus for odd number of times will carry the same sign. So because with squaring, it was a problem for you to decide, because square of a minus is a positive. Minus into minus is a plus, but here it is obvious. Minus will only become cubic value. Coming to this part, the denominator, it is a plus b plus c whole square, that particular identity. Okay. Now putting all of them together and cancelling the common factors. Try to see. This was the answer to the numerator, and this was your answer. This is your answer to the denominator. Do you feel, can you cancel anything? W minus v plus x in the numerator and twice in the denominator. Once it can cancel. Okay, like it's now placed also, no? Like this is numerator. One of the times it will cancel, one of the times it will remain in the denominator, and this will remain as it is. Okay. Only once you practice with your own hands, then cross-check your answers. Going to the next, fourth one. Your main task is to look and see which form of the identity. Square value, square value. So chances are for a minus b whole square identity. Okay, this is easy for you. 2y whole square 5z minus twice of 2y 5z. 2y minus 5z whole square. A square minus b square 5z minus 2y whole square. 5z minus 2y 5z plus 2. 2y minus 5z. Denominator is 5z minus 2y into 5z plus 2y. That's what you have. This is square and this is your numerator answer. This is your denominator. So try and see the common factors and cancel. Chances are they're going to be common factors. Don't leave it as it is. It is your job to simplify and give the most simplified answer. Now see. It's a square. The answer will not matter if I change the 5z 2y minus 5z. No, this is 5z minus 2y. Just a second. Sorry. Okay, that's your numerator. Sorry. 5z minus 2y is your a square minus b square. A minus b into a plus b. Okay. Yes. So one of the times it will cancel. Try and see. I'll change the color of the pen for your better understanding. If I take a minus common in the numerator, I'm talking about numerator. If I take out minus common, I will be left with 5z minus 2y. Is that okay? Is that clear to you? Supposedly 2y minus 5z, taking minus common, but obvious I will have 5z minus 2y. I have to do squaring. I can do the squaring of the whole thing, not a problem. The minus shall, it is the same thing. The answer is going to be same. If you try and calculate the answer of 2y minus 5z or 5z minus 2y, your answer is going to be same, children. Okay, so that's why for a square value minus has no role. And from the denominator, the 5z minus into a minus is going to be a plus. 5z minus 2y can cancel once. Once it will be left out of the 2 values. So 5z minus 2y upon 5z plus 2y will be left. Okay. Fifth part, x square plus x minus 6. What does it make you strike? Quadratic, splitting middle term. I leave it up to you. 3 and 2, 6. Quadratic, 12. Factors, 3 and 4. In fact, we've done very similar types. Numbers also same, just the adjustment of the sign. 3 and 4, 12. And 3 and 4, 7 units. Quadratic, factors of 8 to get you 6. I think 2 into 4, 8. And 2 and 4, 6. Yes. X square minus 9. X square minus 3 square. Okay. X square minus 3 square. So x minus 3 into x plus 3. Write all the factors and cancel the common ones. You will be able to cancel all of them. Only one will be left. Okay. This I am leaving to you as a self-practice. Answer is already shared. We'll go to the sixth part. P to the power 4 minus 16. Okay. Yes, we haven't as such practiced it this year. If it's power 4, you should be able to think of the other number also must be power 4 of something. Okay. It is the power 4 of 2. Power 4 can be written as square of this square. I mean, it can be written as square of square. Power of a power, no? 2 2s are 4. So I can write it as 2 squares square. Or I can call it 4. Not a problem, of course. Okay, call it a 4. That is absolutely same. So it's again a square minus b square identity with p square playing the role of a. So it's going to be a p square minus 4 into p square plus 4, where this itself will be split again into p minus 2 and a p plus 2. After all, 4 is nothing else but 2 square. So again direct identity application. So p to the power 4 minus, whenever it is power 4, it is square of square, and identity number 3 will get applied. but twice. You are applying it once and the second time you are applying. In totality, 1, 2 and 3 factors this expression will carry. The numerator will have 3 factors. Denominator, splitting middle term, quadratic. Oh, so sorry, not quadratic. So sorry, these are square values. 4 is 2 square. It is obvious if you feel quadratic, then you will be able to realize you find the factors to 4 and you will be stuck. It is absolutely normal. If you maybe you are jumping over to quadratic and it is identity and vice versa. Okay. So this is nothing else p minus 2 whole square. One of the p minus 2 shall cancel and rest of the things are your answer. This is your numerator, children, and the denominator will come p minus 2 whole square. One of the times p minus 2 shall cancel. So p square plus 4, p plus 2 divided by p minus 2. Okay. So we have come to the end of the fifth exercise also. Thank you so much for watching. Hope you've understood. You're enjoying the videos. Keep liking and sharing and subscribe to my channel to get more informative videos. Thank you.